Hello, today's objective is that we will find volume and measurements of 3D shapes using discovery and formula. Part one of this video is just going to be finding volume. You should have written down in your packet that the volume of a parallel solid is equal to the area of the base times the height of the solid. I know it's written a little bit better in your packet. And a volume of a point solid is equal to that same thing with a 1/3 out front. So 1/3 area of the base times the height. All the shapes we're going to be dealing with are going to fall into one of these categories. So let's start with this first one. This first shape obviously has a circular base. And if you notice, it connects to a point. So every point along the edge of the circular base all goes down and connects to that same point. So this is a point solid. I know you know this is called a cone, but I want you to make sure you know how it fits into these categories as well. So the volume of a cone, because it is a point solid with a circular base, point solids always start with a 1/3, and then times the area of the base, which in this case is the area of a circle, so that's pi r squared, and then times the height of the entire shape. So I typically use a capital H there to differentiate it from other heights that occur in triangles and rectangles, but you don't have to. Once you get that, you're basically just filling this in and simplifying it. So in this case, we have 1/3 pi times the radius squared, so that's pi times 10 squared. And then the height of the entire shape is 20 feet. And remember that height has to be perpendicular to the base wherever it is, and they did indeed have a little right angle there. So we will simplify this. 10 squared is 100 times 20 is 2,000, and then that's not going to divide by 3 because it doesn't have any 3's in it. So I'm going to keep that as a fraction, 2,000 over 3 pi. And then since this is a volume, our units are going to be cubed. So this is 2,000 thirds pi feet cubed. You can also put the pi in the numerator if you want, or leave it off to the side. Our next example is a parallel solid. You see that there's a rectangle here, and then in the back there would also be a parallel rectangle. Every vertex connects to another vertex going straight across. They don't all connect to the same point like the cone did. So this is a parallel solid with a rectangular base. I know we could have thought of the bottom or the top as the base or the sides. It doesn't really matter for the rectangular ones. So our volume is equal to no 1/3 because it's a parallel solid. So it's just area of the base. So rectangle is base times height. And then you always put the height of the entire shape at the end. This is why I use two different H's, just to differentiate them. But again, it doesn't really matter. When we plug in our numbers here, the base and height of the rectangle that I'm using as my base is 2 and 3 feet. So I'll put in 2 times 3. And then the height of the entire shape would be that 6 that connects the two parallel rectangles. And you notice why it wouldn't have mattered which ones we chose here. All these numbers are going to multiply together anyway. So 2 times 3 times 6 is 36. And this is feet again, so we've got 36 cubic feet as our volume. Our last example in this video is a triangular-based point solid. You notice we've got a triangle on the bottom, or on the base, doesn't always have to be the bottom, and every vertex on that triangle connects to the same point. It doesn't connect to another triangle, which would make it a parallel solid. It connects to the same point, which makes it a point solid. So we've got a point solid with a triangular base. This is also called a tetrahedron, just like this is called a cone, if you wanted to know that. So volume equals, point solid starts with a 1/3. Triangular base means the area of the base is 1/2 base times height. You might not like the two fractions here, but they tell a story. And then the height of the entire shape. I'm going to start plugging in numbers. We've got 1/3. 1/2 base times height. The base and height of the triangle on the bottom is the 6 and the 8 because that's where the right angle is. There is a 10 here, and it's honestly just there to make sure you know not to use it because the 10 is not at a right angle to the 6 or the 8. So we're going to write 1/2 times 6 times 8, and then the height of the entire shape is 12. It's kind of easy when they're straight up and down like this, but you'll see some more interesting ones too where they could be sideways or upside down. To simplify this a little, I do this in my head pretty easily because 1/3 and 1/2 is dividing by 6, and that's just going to cancel out with that 6 right there. So really all we're doing here is 8 times 12, which is 96. One last example with feet, so 96 cubic feet. Our objective today was that we were finding volume of 3D shapes using discovery and formula. You don't have to memorize these formula individually, you just have to know these two.